Hi, I'm Andy Glass with Glass Impressions. Today we're going to build this double-sided maze out of oak and acrylic featuring a pass-through hole to make the maze twice as long. And it's all done on the CNC. Stick around, hope you enjoy.
Tools Today, your source for industrial cutting tools. ToolsToday.com.
I start with a blank of red oak that is 1.5 inches thick and oversized in length and width. I want to keep the blank extra secure during long machining time, so I elected to secure it down with screws and finishing washers. I put 6 screws in total, 1 in each corner and 2 in the middle on the X-axis. I use a V-bit to precisely set the X and Y 0 points. To rough out the pocket for the acrylic, we will be using a Manna tool number RC-2247 with a feed rate of 80 inches per minute and a speed of 18,000 RPMs with a pass depth of 0.128 of an inch. Red oak is a bit tricky and can burn very easily. The feed rate on the previous overlay animation provides the optimum speeds and feeds. Unfortunately, it took me a few seconds into the cut to dial them in. I had some burning on the sides, but that was cleaned up in a future operation. Next, we are going to use a Manna tool number 46316 with a feed rate of 120 inches per minute and a speed of 12,000 RPMs with a pass depth of 0.25 of an inch. We will use this bit for 2 different operations. The first operation will be 2 3/8 inch holes for a couple 3/8 inch wooden alignment pins. The second operation will clean up the rough pocket for the acrylic that we just completed with the surfacing bit. Using the 1/4 inch bit creates the correct radiuses in the corner of the recess to match the future acrylic male piece we will cut a bit later in the video. On the straight portions of the finishing pass, it is only taking 0.10 of an inch, and in the corners it is cleaning up the larger radius, so it is taking a little larger cut. This operation also removes the burn marks on the sides we created earlier with the surfacing bit. To create the channel that the ball bearing will fit in, we use a Manna tool number 46378 with a feed rate of 192 inches per minute and a speed of 16,000 RPMs with a pass depth of 0.1693 of an inch. The quality of cut with this 3/8 inch ball nose end mill was excellent. It created the path in 3 passes and also making a small pass on the other side of the pocket to make it a bit wider to give an allowance for the 3/8 inch ball bearing. It is important to clear the dust and chips on these deeper pass operations. With my dust boot removed for video purposes, I use my shop vac to clean up the dust and chips. We will use a Manna tool number RCK-360 with a tool body number RC-1075 with a feed rate of 60 inches per minute and a speed of 24,000 RPMs with a pass depth of 0.0469 to create the start, flip, and finish text. With the top side completed, we can clean up our CNC work area and remove as many dust particles and chips as possible before removing the workpiece. Then remove the screws, flip the workpiece, and drive the 3/8 inch wooden alignment pins into the holes and down into your spoil board. You will most likely need to pre-drill the screw holes again as they will not line up. Then screw down the workpiece again and do it all over. We will now use a Manna tool number 46190 with a feed rate of 130 inches per minute and a speed of 18,000 RPMs with a pass depth of 1/2 of an inch. We will use this hefty bit to create the pockets for the handholds and also create the profile operation using 4 tabs to keep the finished workpiece in place. I created ramps and lead-ins in both the handhold pockets and outside profile operations. The ramps prevent the tool from plunging straight down, and the lead-ins help create a smoother start of the operation. Both operations were completed in 3 passes while making sure to remove as many dust particles and chips as possible with the shop vac. You will also notice I removed the middle screws as they would be hit by the outside profile operation. I replaced them with aluminum hold downs. With the wooden portions of the project completed, we can now focus on the acrylic needs. I used double-sided tape to secure the workpiece to a flat piece of MDF and then screw it down to my CNC spoil board. I used a Mana tool number 51441 with a feed rate of 5 to 7 inches per minute with a speed of 6,000 RPMs to pre-drill the acrylic for mounting screws. I use a Mana tool number 51405 with a feed rate of 50 inches per minute and a speed of 9,600 RPMs with a pass depth of 0.122 of an inch to make the profile cut on the acrylic. I use the same ramping and lead-in technique we used earlier. The quality of the bit and securely holding down the workpiece created an extremely smooth edge finish. We can now head back to the wood portion of the build by cutting the tabs loose with the handsaw and then heading to the edge sander to sand them smooth. Then at the router table I use a 1/4 inch radius roundover bit to round over all the edges, including the handholds. We can now apply some finish. I use a dark walnut Danish oil. It is easy to apply and dries relatively fast. With the finish dry, I can use the holes in the acrylic as guides to pre-drill the holes in the wood. I should point out that they line up with the higher walls. I then drive a small number 6 panhead screw with a little wax to make installation a little easier.
I hope you guys enjoyed this CNC project. If you have any questions or comments, please leave them below. A big thanks to toolstoday.com for sponsoring this build. If you guys enjoyed this video, please smash the like button, share, and if you haven't already, please subscribe. I encourage you to like my Facebook page and follow me on Instagram for mid-project pictures. Thanks for watching, and I'll see you next time.